see the next one, operation on complex numbers. Let's do the operation of plus, minus, and also multiply. So the tips here is just separate the real part and the imaginary part for you to do your calculation. So let's look at the first one and then separate the real part and the imaginary part. Okay, so 3 minus 5 is minus 2. And then when you solve this, this is minus 3i. So this is your answer in terms of standard way, which is a plus bi. If you want to specify your a is minus 2, the real part. The imaginary part, b, is minus 3. Let's see the second question here. You have minus inside and then open up. So it becomes minus 4 plus I, minus 2 plus 5i. Separate the real part and imaginary part and then solve them until it becomes minus 6 plus 6i. Let's see the next one. This is multiplying. Okay, so what you should do is just multiply one by one. Open up this one. Okay, so it becomes like this. Whenever you see I squared, straight away change to minus 1. So minus 3 times minus 1, this is now 3. Okay, then in order to solve this, just solve the real part is 8 and the imaginary part, this is 2i. Next, you must know what is a complex conjugate. So in order to do our calculation after this, we need to multiply our complex number with its conjugate. So if z is a plus bi, therefore the conjugate symbol is z bar. Okay, you have a bar up here. So this is just equal to a minus bi. It's the same number, but the symbol here is the opposite sign. So let's see this one, 5 plus 7i. So the conjugate will be 5 minus 7i. Next, 4i. So 4i here means 0 plus 4i. So in order to find the conjugate, it is 0 minus 4i. So let's see the next one, minus 8i plus 5. So be very careful here. Arrange it first into standard form. 5 minus 8i. Now let's find the conjugate. The conjugate is 5 plus 8i. So be careful and not getting confused with the shape. Make sure you change it to standard form first. Now let's see the properties of conjugate. What happened when you have a plus bi plus a minus bi? So for this one, let's just open up a plus bi plus a minus bi. Okay, so bi minus bi is 0. So you're left with a plus a, which is 2a. The second properties of conjugate is when you multiply the conjugate. So if you see this is z, multiply your z bar. So z is a plus bi, z bar is a minus bi. So when you multiply them, this will become a squared plus b squared. Okay, why does it become like this? Okay, so let's see what will happen if we multiply with the conjugate x plus y multiply x minus y. This is equal to x squared minus y squared. So a plus bi multiply a minus bi is equal to a squared minus bi squared. A squared is already simplified. Let us see here. What is bi squared? This is equal to bi squared. So whenever you see I squared, straight away change to minus 1. So minus times minus. Now this will becomes a squared plus b squared. So this is the proof of this property here. So after this, if you meet the multiplication of the conjugate, a plus bi multiply a minus bi, just use the shortcut a squared plus b squared. Let's see now this example here. Express this in the form of a plus bi. So you see now that this is a rational complex number. You have a fraction here. So in order to make it in the terms of a plus bi, you don't have any denominator. So we need to get rid of the symbol of I in your denominator. So the only way that you can do to get rid of the symbol I here is just multiply the conjugate. Okay, so what is the conjugate for 2 minus 3i? It is 2 plus 3i. So if you multiply something in denominator, make sure you multiply also in the numerator. So for numerator, just write it side by side. Later on, we'll multiply it. So now for denominator, let's use shortcut. 2 minus 3i multiply 2 plus 3i. So your A is equal to 2, your B is equal to 3. So let's use shortcut. When you multiply it, it becomes A squared plus B squared. This is from the properties of conjugate. So now let's finish this up. This is over 13. And then let's multiply your numerator. Once you have I squared, straight away change to minus 1. And then simplify. And lastly, separate your real part plus your imaginary part. If you need to extract out the A is 4 over 13. And B, the imaginary part, is 19 over 13. Let's look at another question here. 7 minus I over 3 minus 5i. So we want to write it in terms of standard form of complex number. So we need to get rid of the I in the denominator. So the way is we need to multiply the conjugate. Let's open up. Your A is 3. Your B is equal to 5. So let's use shortcut here. A squared, 3 squared, plus B squared, 5 squared. And then this is 34. How about the numerator? Expand out. So I squared is minus 1. Simplify them and then split your real part and your imaginary part.